Qualcomm and from our partners, companies. So, second part of the day, we are going to the keynote session from the presidents of Qualcomm Mobile Computing, Cristiano Mon and Dr. Murthy Renducitala. They will cover the progress and the next roadmap technology development for Qualcomm Mobile Computing. We will have also Jens Schuster-Bochum from Vodafone, CEO of Vodafone Germany. And Jens will cover the LTE rollout in Germany by Vodafone and other items. But we are very much excited to have Jens with us. So, saying that, let me welcome onto the stage Cristiano Mon and Murthy Renducitala.
Good afternoon, everybody. So I have the challenge of having to do this after lunch. So it's not the fastest walk, but I'll try to do my best. So good afternoon. It's a pleasure to be here. As Enrico said, my name is Cristiano Mon. I'm together with Murthy responsible for Qualcomm mobile computing semiconductor business. It's my first time in Berlin, so I'm very excited. I wish I had a little bit more days, but we're looking forward to come back next. And I appreciate all of you coming to this event with Qualcomm. So one of the things I'm going to talk today is a little bit what we're doing in the semiconductor business, actually to realize the vision presented by our president, Steve Mollenkopf, looking at the mobile platform and how is that influencing the multitude of devices and how we are developing products, hopefully to be successful and be the silicon of choice in those devices. So we'll start with that, talking about some of the things we see in the mobile phone today. I think most people that remember Qualcomm in the very beginning, we started as a modem company developing, digital communications technology. And one of the things over all of those years looking at the cell phone and the attributes of a cell phone as the cell phone went from a basic voice communication device to today's smartphones has not changed. People want to be connected all the time, want to be reached, want to be efficient in power. The battery has to last all day, and it has to have the scale. And the scale is actually very important. One of the things that people don't realize, there are more cell phones today than toothbrushes. There people won't have a toothbrush, but they have a cell phone. And it's actually a very large scale device. And the technologies that we had to invest to enable those things in today's devices actually influencing other devices to be connected and have some of the behavior of the cell phone. So we're really entering the era of what we call the smart connected devices. And the technology from the cell phone is actually starting to influence devices on the connectivity side, into new connected opportunities, what we call the Internet of Everything, the machine-to-machine segment, the connectivity and the ability to control and communicate devices that are part of our daily lives, as well as influencing the architecture of other consumer electronics. And actually, that's the more interesting part. I think cell phones are changing the way computers are today, going into the post-PC era with the tablets and the connected tablets and the tablets that can last your entire day for both entertainment and creation, and as well as going to the TVs. The TVs are becoming smart. And by being a company that had invested into the technology to make the smartphone viable today, we think we're very well positioned into succeeding in providing the technology for those other devices. And that's what my colleague Murthy will be talking about today, into the details of those technologies that we're investing. So one thing that we have adopted as a strategy and how to develop semiconductor products that has the ability to enable that vision in all the devices, we had to pick what we call a four-step approach. So the first one is we have to have technology superiority, and actually we have to have the ability to own the technology of every single element that drive that platform. So as a company, we have been today the largest wireless semiconductor company. We ship more wireless modems than any other company, but also not well known to the public. We're the largest DSP company. We ship more digital signal processor. We're the largest GPU company. We ship more graphical processors units. We actually one of the largest producer of CPU, because same thing with GPS, and because we have developed all of those technologies that are required into today's smartphones and tablets. And we have the ability to optimize that for those attributes of mobile that never change. The battery has to last all day, needs to be connected, and it'll be always connected. The second thing that we do is we bet on silicon integration. I think in the history of semiconductor, every company that bet against integration has not been very successful. And I think we believe that by integrating all technologies into a single piece of silicon and have a system approach, it's actually the winning solution for today's devices. And I think we're very happy with the presentation made by our colleagues from Nokia. We're actually very proud to be able to provide a semiconductor for Nokia. The ability to enable all of the functionality that you wanted to see in today's smartphones with a single chip is actually the strategy we employ. And then the ability to have a roadmap that we can serve multiple tiers of devices, ranging from affordability and the transition of the 2G smartphone into a 3G smartphone, all the way to a connected computing device. Modem has been the core of what we do, and one of the things that we continue to invest is in the modem technology leadership. We started as a modem company with CDMA and double CDMA. We're today the leading company in LTE, and our goal is to be able to continue to invest in modem capabilities to enable all of those devices to be connected. The experience of a device which is connected 100% of the time and does not require the user to have an understanding when he's connected, when he's not connected, it's what differentiates Qualcomm modem technology. And the other important thing is we're transitioning to the era of the what we call the post hard drive. I think all of the applications and your contents not only resides in your device, but resides in the cloud. And the ability to be connected with the cloud constantly, regardless if you are on a local area network, on a wide area network, is what's going to differentiate the future, today's and future experience of the devices. So that's clearly an area that we invest and will continue to invest. We also looking to provide multiple platforms. We have been, providing devices across 6 different operational systems, and we'll continue to do that as much as necessary to provide a very rich and competitive marketplace for consumers and for partners. And one of the things I think it was discussed in today's presentation about the evolution of computing. WinRT combined with Windows Phone, I think it's a true representation of this new era of devices, when what you do in your phone is actually going to be what you do in your computer as well. Another approach, when we talk about the system approach, is to recognize that it's not only about semiconductor, but it's actually developing a complete solution that allows all of our partners, not only the device OEM, but also the high-level OS companies and the application developers, to have access to a complete ecosystem. So our approach is, besides just providing an integrated silicon with all the functionalities, we also provide a number of platforms. So we provide a reference design, developer tools, and ability to support customers with a variety of devices. So when we provide chipsets, we recognize that there's a need for applications to be developed in parallel to the chipsets, for devices, phones or tablets to be developed in parallel chipsets. And we provide a complete suite of tools ranging from development boards to a complete device reference project for both tablets as well as phones. And we also have a number of online tools to promote that development. And we also, with the ability to provide reference designs in the class or the category of entry-level affordable devices, what we call the 2G to 3G migration, we also provide a reference design for that affordability. The devices that are replacing today's feature phones with entry-level smartphones. And with that, we're able to provide over 50 models, over 100 designs from 40 OEMs using our tools and reference designs. So I think that's just to give an idea of the whole ecosystem around the chipsets. And on the roadmap, we have been trying to provide a solution for every price point, ranging from, as I mentioned, the entry-level smartphone, which is now in the sub-$100 category, to multiple devices, all the way to the high end, to the computing, and then with the MPQ, the smart television. And I think the TV is also becoming the evolution of what used to be the family desktop. A connected TV in the home, whether it's a TV or a DMA box. It's actually going to have the same experience that you have on a tablet and your phone, and it's going to be another panel that you can exchange content for your personal device. And therefore, we're looking into that's the evolution of the industry, and that's where we're investing in semiconductor. And all of this is aligned with our view that our products are enabling all of our customers and users to connect more, reach more, and create more in the biggest platform, which is the mobile platform, is the biggest platform in mankind. With that, I'd like to invite to the stage my fellow co-president for QMC, Dr. Murthy Raghuchandala.
Good afternoon, everyone. I hope everybody can hear me at the back. So, picking up on the theme that Cristiano concluded with, connect more, reach more, create more. Well, it's very simple to take that to the next stage and conclude that great products come from the integration of great technology in an expert system context. And one of the things we've spent many hundreds of man-years doing and many billions of dollars spending is being able to regard our technology portfolio as world-class. If you look at the elements of technology we have to bring together, they span all the way from the CPU environment into graphics, very complex power management subsystems, the complete panorama of multimedia technologies that we have to have in a phone, going from video and audio and image capture capabilities, ubiquitous connectivity, whether it be modem-based, whether it be Wi-Fi based, the ability to store and transfer large amounts of data around a system, and appropriate memory technologies and structures to be able to do that with, the enablement of a multitude of software platforms that allow our OEMs to scale across multiple different operating systems, integrating complex RF technologies to be able to provide economies of scale when an OEM is looking to play on a global platform. For example, today we are facing somewhere in the region of 50 different bands of LTE that we need to support. And with the advent of carrier aggregation not too far off, the RF picture becomes even more complex. Position location is a fundamental technology that now needs to be embedded in every handset that is shipped. And as I've said, ubiquitous connectivity through wireless WAN is now something that I think really is looked upon as essentially a hallmark of what differentiates a really great handset from something that's mediocre. And all of these technologies are required to be mastered in a world-class context. It's not good enough just to integrate. You have to integrate the best. And another thing to really understand is that the real power of all of these IP technologies comes to the surface when they're integrated in a manner where the data transfer that occurs between each of these islands of IP is optimized in a manner where the system is able to fully exploit the capabilities of the core. As we'll show you later, just having great IP put together in an immature way doesn't necessarily lead to a compelling user experience. And I think we'll show you some data that shows how much care and attention we pay to the systems engineering of our products in order to be able to make sure that all of the great IP we put together is actually able to deliver an experience that is much greater than the sum of its parts. So as I said, what we bring to the table is not only the mastery of the individual IP cores, it's the integration into a single piece of silicon that gives an uncompromising user experience. Now, specifically, for example, in the modem technology area, I think a lot of us are congratulating many European operators on the advent of LTE in Europe. Well, a truth that may not be that well known to everybody in Europe is that Qualcomm is actually now delivering its third generation of LTE technology. We were the world's first company to deliver multi-mode LTE way back in 2010. And we're now entering the third generation of our LTE modem technologies, and we support 7 different air interface modes. They're all written up on the slide behind me, but suffice to say that with our third generation of modem technology, we have provided global ubiquity in terms of wireless WAN connectivity. There is no part of the globe, no RF band that currently supports LTE that Qualcomm does not support. We will now move forward with modem technology that supports TD-SCDMA as well as TD-LTE, and we're able to support that in a multi-mode context to the degree that we can support 2G, 3G, and 4G technologies ubiquitously on a global scale. So again, one of the things we've really tried to do is to make sure that we have not only mastered the technology from an IP point of view, but reduced it to an implementation where it allows an OEM to really invest in the scale of global production that is necessary now to be able to really meet the diverse LTE requirements going forward as 4G ends up proliferating multiple bands in both an FDD context and a TDD context. Now, going back to some of the attributes that I think pay testament to the systems engineering expertise that we have been able to apply to our roadmap in Qualcomm. One of the things that's very clear is that just having great IP, as I've said before, doesn't lead to a great product. For example, if you can see the numbers on the slide in front of you here, what we're looking at, ladies and gentlemen, are data derived from a dual CPU architecture, the S4 8960 class of product, a dual CPU architecture in comparison to benchmarks that have been achieved by competitor quad-core architectures. So essentially you have in the Qualcomm argument an architecture that requires 2 CPUs, and we're able to generate a performance and user experience that way surpasses what others have been able to achieve with the utilization of 4 cores. Now, as you can see here, performance can be measured in multiple dimensions. Here we've looked at multimedia and gaming, web browsing, and application performance in terms of initiation and overall startup times for applications. And as you can see, what is evident in this slide is that not only does great IP need to be available, but it needs to be integrated in a system-aware context. And that's what we've done at Qualcomm. We've been able to really engineer the best of our IP and put it together in a package that has really been able to optimize the data transfer that has to happen between the various cores in our MSMs to really unleash the performance that the silicon is innately going to be able to provide. And I think what we are really looking at is how we continue to perfect optimum performance, irrespective of metrics of technology that one could argue. Quad cores, 6 cores, We talked about quad-core graphics cores as well. They are only relevant, those numbers are only relevant in the user experience we seek to provide to our end users. And again, moving on to our own quad-core implementations, as you can see here, as we normalize the benchmarking conditions between our quad-core and our competitor quad-core products, early data already shows a dramatic benefit that's been able to be derived from the Qualcomm architectures. Again, it not only speaks to the supremacy of our IP, it speaks to the supremacy of our systems integration. And this is even more important as you go forward in looking at the end user experience. All of the benchmarks we've talked about are relevant in the context of how they are precursors for how a product will behave in the hands of an end user. Richer and more powerful applications. The application startup times are in the flash of an eye. The frames per second basically make the videos and the application buttery smooth. Stunning multimedia and gaming experiences. Image capture that basically makes it look as though you're reliving the moment in exact detail. Really, really fast web browsing, where essentially the speed of your web page is as fast as the way you can move your finger on the screen or select a page. And to provide high performance battery life, where essentially once you pocket your phone in the beginning of the morning, you really don't have to worry about putting it back into the charger until you get home at night. It lasts a full day and more. All of that comes from great IP integrated in a very, very expert systems-aware context. And then again, another challenge we're going to face as we go into the advent of multi-core technology. The biggest challenge we face, I believe, in the mobile design space going forward is how you're able to constrain the power of 4 CPUs running at 2 gigahertz plus, quad-core graphics cores running at 600 megahertz plus, Cat4 LTE transferring 150 megabits of data per second. Put all of those in either a semi-simultaneous or an aggregate simultaneous context. You have a very, very, very complex thermal envelope to manage. Most PAs are probably going to be in the region of 50 to 60% efficient. Most silicon is going to have an efficiency in that region as well. So if you look at the amount of power that is going to be generated by the subsystem that you power a phone with, and how much will essentially be dissipated in heat because of inherent silicon inefficiencies, one of the challenges we have is how we manage the thermal envelope. And we at Qualcomm have put a tremendous amount of effort of being able to develop very complex thermodynamic management executives which can keep all of that power in balance and in great harness. And as I think you'll see both in the slide in front of you and a video coming up, it's very, very easy to get into a situation where you get into a user scenario where, although the great power you have under the hoods of your chipsets is great, if you can't harness it in a manner that leads to a profile that is thermally balanced, you can get into a lot of trouble. And I'm going to go to a video which I think really speaks volumes as to what that really means in an end-user context.
Thermal efficiency has become very important because from an end user's perspective, the phone or the tablet that a user is using gets so hot at times that it becomes annoying. We have 3 devices, a Qualcomm-based phone and 2 competitor-based devices. The thermal camera shows the thermal footprint that the 3 phones leave when running a CPU-intensive test. One way to show the results is via a heat map through a thermal camera. What we are trying to compare is thermal efficiency when the CPU is delivering peak performance. As you can see, the phone based on Qualcomm's chipset is much more thermally efficient compared to the competition. Another way of showing results is by melting butter. Yeah, melting butter. Butter melts at 35 degrees Celsius. As you can see, the phone based on Qualcomm's chipset is much more thermally efficient compared to the competition. One of the phones that is heating up the most is heating up to 55 degrees Celsius. That's hot, that's really hot. Qualcomm's Snapdragon S4 is the coolest kid on the block, and we mean it literally.
So somewhat to the flippant video, but conveying a very, very important message. One is all of that power that's going to melt all of that butter is power that you are deprived of in terms of being able to get through a day of heavy usage of a smartphone. And secondly, what it also exemplifies is being able to allow an end user to have his phone always operate at a point of peak performance without getting into issues of thermal control, which means various elements of the capability of the phone need to be throttled back. Clearly, the only way you're going to manage a situation where you have a problem of escalating thermal balance within a phone is to simply shut down all of the elements in the phone that are actually consuming energy and dissipating half of that due to inefficiencies in its architecture. And therefore, what we've really been able to do is really create a balance between power and thermodynamic balance that allows us to maximize user experience and maximize battery life. When speaking of battery life, one of the things that's become more and more standard in the way attributes such as power is measured is what we call days of use modeling or scenario modeling, whereas instead of just talking about individual attributes, about hours of video playback time or hours of talk time, really the metrics that are much more fundamental and relevant now are what we call scenario or usage-based modeling in terms of power. And some statistics that are worth sharing with you, for example, there's a couple of scenarios we've modeled which are very much representative of the kind of user groups that really put smartphones through their paces. Scenario one involves a mixed usage mode of web browsing, streaming TV to your phone, as well as listening to music. And in like-for-like conditions, the S4 level of processor was able to achieve almost 2 hours more than an equivalent spec pass. And in the second scenario here, where it was a mixture of video chat, web browsing, and taking pictures, we achieved more than 1.5 hours more of extra battery life. And as I say, at the end of the day, one never really wants to feel a sense of apprehension in whether your typical usage model will ever be governed by your ability to be near a power point and charge your phone. I think what we've really tried to do is create architectures that allow a vibrant and fully unrestrained usage of a phone in many, many different usage scenarios, independent of whether you're a youth, surfing the web, listening to music, browsing the web, or whether you're a professional whose main goal is essentially making sure they're up to email, synchronicity, making lots of phone calls, and making sure that essential web material is available to you at your fingertips. So again, a tremendous amount of effort in terms of system efficiency, battery management, and thermal management. So what has all of that technology mastery and systems expertise really gained us from testament to success? Well, I think the slide in front of you really, in our mind, is the truest report card that can exist. And what we have today on the Snapdragon processor family is over 50 manufacturers making use of Snapdragon technology from Qualcomm. More than 400 devices announced and launched already. 400 others are already in development, and over 30 tablets in design. And amongst all of those statistics, about 175 use our latest generation of AP processor, the S4. So clearly, I think a lot of OEMs and a lot of end users have been able to discern for themselves, maybe in less numeric form and less technical terms, the benefits I've shared with you today. But that really is what we're doing to drive mobile communications forward, innovating across the panorama of technologies that you now have reposited in a cell phone, and delivering that in a balanced and well-harnessed manner that allows everybody to get the user experience they want with the battery life they want and in an uncompromising fashion. And with that, I think I hand back to Enrico to introduce our next speaker.